Good evening. Sorry for the delay. We had a connection problem. Welcome to the Lycée Joseph Galliani in Toulouse. Today I am happy to host the 8th webinar concerning the 4i4u project. The 4i4u project is a project co-financed by the European Institute of Technology. It's a consortium of cities, high school, colleges, companies, clusters, and we have the objective to develop and to sensibilize the young learners about the urban mobility for today and for tomorrow. And today the topic of this 8th conference is when smart mobility means smart infrastructure. So I'm very pleased today to welcome our speaker, Pierre-Emmanuel Maire, which has about 27 years of working experience in the automotive industry. And today he is the director for new business model of Continental Automotive. So the floor is yours. Thank you. Have a good
Thank you.
webinar.
Hello, everybody. So, thank you for the introduction. I say my name again. So, Pierre-Emmanuel Maire. I am Director New Business Models at Continental Automotive. I'm located in Toulouse here. My current activity is focused on smart infrastructure systems. I will present two of them. And for this, one key topic in my job is to enable partnerships. I will come back to this. But before going into the smart infrastructures, let me start with a short presentation of Continental. You see here on the bottom left the vision on mobility and the associated freedom. And you see also our mission statement, which covers safety, environment, information. I will continue with some key figures about Continental Group in 2021. So you see roughly 34 billion euro sales, a bit more than 190,000 people. Spread over more than 500 locations in 58 countries. You probably know Continental as for the tires, but it's not only tires. So tires are 35% of the sales, but round about half of the sales are with mechatronics and software systems, or more commonly automotive electronics. And this company is 150 years old, meanwhile. A last word about Continental. So the sales we make to 61% with automotive car makers, which includes also the tires, and 39% with other industries like big industry conveyor systems, as you see on the picture on the right. So let's come back to smart infrastructures, and especially I will talk about intelligent intersections and automated valet parking type 2. So our smart infrastructure system development is organized in a platform with, on one hand, the intelligent traffic management. This is where we have the intelligent intersection, and we also have the wrong way driver detection, which is especially important in the USA. And on the other hand, we have intelligent vehicle maneuvering, either at vehicle assembly plants. This is what we call IOM, and at parking lots with the automated valet parking type 2, And as I said, I will focus on intelligent intersection and AVP2. Let's start with intelligent intersection. So why do we do this? We do this because this increases the traffic safety for all users. For example, using V2X communication. V2X, maybe if you don't know what it means, it simply means vehicle to X. So that means the ability of the vehicle to interact, to communicate with other devices. It can be another vehicle, it can be an infrastructure, it can be any device which is capable of such kind of communication. And intelligent intersections are also good to increase efficiency. So that means improve the traffic flow by providing more accurate and really reliable data for drivers and for traffic management. So basically, it's about managing complex intersections by applying automotive technology, which is proven, highly reliable at the intersections. And so, for example, we use our radar sensors. So radar sensors which we developed originally for vehicles, which are embedded in vehicles. We take exactly the same product and we implement them at intersections. Today, the traffic infrastructure is transforming, and the two main drivers shaping this transformation are, on one hand, the digitalization and technology evolution, which is a transformation on its own, by the way. And on the other hand, there is increasing challenges with more and more connected and autonomous vehicles. So intelligent intersection in this transformation will become an enabler for future mobility in cities. For example, helping autonomous vehicles to drive through an intersection in a good way without accident. It's a bit long. So let's look at intelligent intersection in a video. So as I mentioned before, we use advanced sensors to detect and track traffic participants. So, and the aim is to increase safety and efficiency of the traffic. So usually at an intersection, we will equip each corner of the intersection with 2 sensor modules in order to cover the entire intersection. And the sensors we are talking about here are cameras and radars. So you see, this is the kind of picture we can generate from this system, and we detect vehicles, pedestrians, cyclists. And with this system, we can implement functions to increase safety and efficiency, and I will tell you more about this. So, and this is absolutely consistent with our mission statement, which I mentioned in the beginning, the Vision Zero, so means Vision Zero accidents, so safety. So, as we have seen, so at an intersection, we implement our system in a modular way. So, and components of this system are sensor modules, usually 2 modules at each corner. You see also, you don't see my mouse, but you see also, let's say, in the bottom place in the middle, there is also what we call the RSU, which is the roadside unit, which is the module for the V2X communication. The traffic light controller is connected to all these sensor modules, and the traffic light controller, the cabinet, hosts our computing unit on which we run software. software modules for safety, for efficiency. And this system can be connected also to the traffic management system of a city. And it will provide this system also with data which can be analyzed and used for improving safety and traffic. You see the legend, sorry, I should have clicked once more. So, one more word about this. For the V2X communication, we have a hybrid system. Why? Because there is not only one standard. There are different technologies used. So our hybrid solution is able to access 5G, 4G, 5G networks. And for the V2X communication, we can use both technologies, either DSRC, which is basically Wi-Fi, or very close to it, or we use what we call CV2X, so cellular V2X, so using the cellular network. So here you see some pictures with examples of implementation. So here, those are pictures of crossing in Huntington Beach in California, USA. So you see in the middle, this white box here is a radar sensor. On the top, on the left, or on the bottom right, you see the camera. Some further pictures you see here on the next page at another crossing. This is in Auburn Hills in Michigan, USA. Here also you see, maybe not completely easy to see here in the room, but yeah, you see cameras, radars, and here the roadside unit. So let's look a little bit more into the system and what we do with it. So what we need to do when we want to install an intelligent intersection, once we have installed all the sensors and the system, the hardware, we need to build what we call a comprehensive environment model of the intersection and of the roads leading to the intersection for 150 to 200 meters. This is round about the area we can survey. And basically what we do is, so here you see an example of, so you see something happening at a crossing. This is a video of it. And you see here on the top, you see how we translate what happens at the intersection into those blue boxes. So each blue box is a vehicle. Maybe you have seen some purple dots, which are pedestrians. And once we have done this, we can use this environment model to implement functions. We can implement very simple functions for an intersection. So like the detection of what we call the stop bar. So detect that vehicles are stopping at the intersection. Detect pedestrian. So we can do also more advanced functions, safety functions. And here, let's look at an example. So this is an intersection. This is a vehicle approaching the intersection, wants to turn left, and there is a warning here from the intersection because there was a vehicle which could have run into an accident with it. And so here what you have seen, this was a bit quick, maybe I will play it one more. The intersection detects that there is a potential accident here and warns the vehicle through V2X communication. Be careful, there is a car coming. Oops, sorry, I forgot one. And finally, we can use also the system for advanced analytics. So that means we can record for a long time what happens at an intersection. And using this data, you can analyze what happens. For example, if you want to check, okay, between 11 o'clock in the morning and 3 o'clock in the afternoon, how is the traffic at the intersection, and doing so, you may be able to improve it. So talking about, so this is what we call a heat map, and here you see another example of heat map. When we have installed our sensors at an intersection, here you see, what you see are all the dots is what is detected by our radar. And you see here 4 different colors, so for means data from 4 different radars. And you see here, for example, these 2 streams, these 2 branches are not well aligned, meaning that when we install such a system, first we check that we can access the data, but then we need also to calibrate. And once you calibrate, you align basically the data in order to have the right environment model, just as an example. So I will go quick on this. There is a lot of text, but I will not read everything. But basically, just to show you quickly, we have basic features with the intelligent intersection. So stop bar detection, we have seen it already before. We can detect in an advanced area, like 150 meters before the intersection, we can do some spatial detection here. For example, if you see a lot of vehicles in this area, you can decide to turn the light of the traffic light earlier to green. Dilemma zone, this is you can extend the yellow light at the intersection if there is a vehicle in this area, and detect also groups of vehicles. If you see a group approaching, and you know normally the traffic light would go red, you wait a little bit so the group will pass the intersection. And there are more advanced features like pedestrian detection, bicycle detection, and also V2X messages. I will not go too much into the details, don't want to get boring. And here again, the mention about the hybrid V2X communication. In conclusion, about intelligent intersection, what are the benefits? We have, with intelligent intersection, we can increase safety. We can also, I mentioned this in the beginning, we can enable autonomous driving. So basically, especially when an intersection is complex, autonomous vehicles will need help to pass through an intersection, and we can provide this help. And we can reduce congestion, and this way reduce pollution. So one feature I mentioned before, when you detect a group of vehicles, or when you detect a big truck, and if you don't turn the light to red, you let them pass, so then they don't need to brake, and they don't need to go to speed again afterwards, so you can save a lot of emissions if you optimize the traffic at intersections. So this was my presentation about intelligent intersection. Now it's time for the second smart infrastructure system I want to present to you. And this is about intelligent vehicle maneuvering. And there are two paths, let's say, or 2 portions of this system. We can implement this system at vehicle assembly plants at the end of line. For example, at an assembly plant of Renault or Toyota or whomever. And we can also implement this kind of system at parking garages, at the airport, at the shopping mall, at the Lycée Gallieni, anywhere. And this is what I will focus on. And here, this is about remotely maneuvering vehicles. So that means the infrastructure takes control of the vehicle and will guide it with low speed, because of safety, to to a place of parking, or you will see there are more applications to it. So before moving further into AVP2, I wanted to emphasize on the fact that there are 3 different types of automated valet parking according to the ISO standards 23374. The type 1 is, and the difference between the 3 is where is the intelligence. And the type 1, the intelligence is in the vehicle. So basically it's an autonomous vehicle which is able to park by itself. The type 2, which is our focus, is the intelligence is in the infrastructure. So the infrastructure will guide the vehicle. And the type 3, which is in focus especially in Japan, is a mix of both. So you have a little intelligence in the vehicle and some in the infrastructure. So as I said, we will focus on the type 2, so the infrastructure-based system. So, and let's look into it with a video. So, you drive your car to a drop-off zone. So that's a place where you can step out and go to the shopping mall or enter the school. And you use an app on your smartphone. And from now on, the infrastructure is taking control. How is it taking control? Using this, and these are just standard cameras, standard surveillance cameras. Obviously, the system needs to be safe, because if a pedestrian crosses the way of your car, it has to stop, obviously. You can implement multiple services. So, for example, while you go shopping, your car will be washed. Obviously, the system is able to target a free parking spot and will park the vehicle into this parking spot. So this video has been registered at the mobility fair in Munich in September last year. So, and once you return, you have you can call the car on your app, and your car will join you at a pickup zone. It can be the same zone as the drop-off or different one, depending how the layout of the parking lot is designed. Here in this case, the drop-off and the pickup areas are at the same place. When we have done this demonstration at the Munich Fair for Mobility last year, we have shown that we are able to run the system with multiple brands of vehicles. You have seen a Ford, a BMW. This is Cariad, this is Volkswagen, and so on. And here you see Copernicus Automotive. I told you in the beginning that part of my job is to take care of partnerships. Copernicus Automotive is our partner for this kind of system. And by the way, this reminds me, I forgot to mention it talking about intelligent intersection, where our partner is Iteris in the USA. I'll come back to it later again. So now let's look into how is the system designed. So let's look into the functional block diagram. So what do we need for this system? We need obviously a map. We need to have data about the environment, the infrastructure, a map of the parking lot, and we need sensors. And as you have seen, the sensors are cameras in this case. So using the sensors and using the map, we can localize. We can localize a vehicle. We can localize what is around, and we have perception, so we can see what is happening around the vehicle we want to drive automatically. With this, we build, again, as we do for the intelligent intersection, we build an environment model. And there we apply artificial intelligence. And this enables us to have prediction. We have then the mission planning, so we know what we want to do. We want to take the car from the drop-off zone to a free parking spot. This will be derived into maneuver planning. We know where to go. And then more precisely, trajectory planning. And this is something we share, then we send to the vehicle. And then inside the vehicle, there is a vehicle control module, which translates the trajectory planning into the actuators. What are the actuators? Starting, stopping the engine, accelerating, braking, and steering. And what happens is correlated with the system in order to adjust continuously what is happening. To be compatible with such a system, we need also something on the vehicles. We need the vehicles to have electronic stability control. This is for braking. We need electric power steering. We need the electric parking brake, wireless communication. We need an automatic transmission. Manual gear doesn't work. And we need also to remotely start and stop the engine. But the good news is today's new vehicles, they all have this. And especially electric vehicles, they have this. So most of the new vehicles today are ready for such a system. I'll go now a bit into technical highlights, but I will not go too much into the details. The system is based upon, as I mentioned already, what we call low-cost sensors, because we use really standard cameras. Standard cameras anyone can buy on the market. These are the cameras which are used to monitor parking lots, to monitor houses, and so on. Very, very simple cameras. In some cases, we may use a bit more complex radars and more expensive sensors like radars or lidars, for example, for narrow passages. You see that we can reach 10 centimeter positioning accuracy, so which means also we can detect objects which are just 10 cubic centimeters. And because it's low cost, it means we can use a lot of cameras. So typically, to give you an example, on the parking lot, if we want to implement the system for an area of 100 square meters, we will implement, depending on the configuration, but we may implement from 60 to 80 cameras. And we use artificial intelligence, which is able to understand what the data from the cameras. And so that means it's able to understand what happens really real time. So you have seen before in the movie, if someone is crossing the path of the car, obviously you need to stop. And obviously the system must be safe. There is no way for any accident. So it's made also for mixed traffic. So that means the system is able to drive a car, and you can have other cars driven automatically or by people crossing the driven vehicle without any issue. For the computing unit, in fact, we use also here quite low-cost systems. In fact, we use graphic cards, basically. Very powerful, but graphic cards. Functional safety is a key topic. Functional safety means whatever happens, there is no way we can afford an accident, and obviously no way the system shall injure anybody. So functional safety is a key topic, and this is something Continental is an expert of. You see here the reference also to the main safety standards we are referring to. So this Continental Copernicus solution is ready for automated valet parking, and even future use cases. You have seen before in the video there are more services you can think of, like washing the car automatically, or for an electrical vehicle automated charging. Let's go even a bit deeper into the system. I hope you can still afford it. So, in order for the system to understand what the video cameras are seeing, we do what we call pose calculation. Pose is means the 3D position of a vehicle, for example, or an object, and even more including the orientation of the object for a vehicle, for example, the way of driving. So for this we use artificial intelligence, and especially we use a so-called single shot detector, which is a very powerful model for object recognition and classification. And we also perform fusion of data from several cameras, in fact. So we look, this is why I told you before, for an area of 100 square meters, why do we implement so many cameras, you could say, like 80 cameras? Because in any spot, we need at least 2 or several cameras to look at the objects, and we use data fusion. For example, we use an extended Kalman filter for this, and with this we generate again the trajectory planning I was talking about before. And once we have defined the trajectory, we send it to the vehicle, and here again we will do some fusion of data inside the vehicle with the what we call the vehicle odometry. Let me go into this. The odometry, this is the use of data from the motion sensors of the vehicle to estimate the change in position over time. So, for example, the speedometer of the car is part of the odometry, right? And the fusion of with the odometry we do on board of the driven vehicle. So for this, either we develop the software and we provide it to the car maker, or the car maker can develop it on its own based upon our recommendations. And here, for each vehicle, for each car maker, there is specific adaptation. And last word on it, we do this fusion, or we recommend to do it on board because of less latency. If we can do it also inside of the infrastructure, but then you have more latency because of the communication with the infrastructure. Oops. Okay. This is the last but one page. So just to emphasize again on the ISO standard for automated valet parking. So all the pictures you see here are from this ISO standard, or a part of them, because there are much more. And in fact, our system covers all the features defined in the ISO standard. So you have basically what we have seen before in the video, the drop-off, the pickup zone, and the even the change of parking spots, the ability to drive on the ramp, the ability to deal with mixed traffic, what else? The ability to detect also hidden objects. So for example, if you want to park the car into a spot, like driving backwards, if there is a kid on the parking spot or someone lying down, obviously you cannot drive on it, and you need to be able to detect it. So in conclusion, what are the benefits of automated valet parking systems? And here I'm referring to the ISO standard again. So this standard contributes to reaching sustainable development goals in the area of industry innovation infrastructure for sustainable cities and communities, and as a climate action. Why? Maybe one more word about this. We know that around about 20% of the CO2 emissions in the cities are generated by vehicles searching for a parking spot. So if you can optimize parking, you can reduce also emissions. And that's it from my side. I'm ready for your questions. Thank you.
Thank you very much, Mr. Maire, for your presentation and this very impressive technology that you have developed in your company. Maybe some people in the room have some questions. Vous pouvez vous poser une question en français si vous voulez. Moi, j'en ai deux. So my first question is, how long did it take you to develop this kind of technology? How many people? How many years? First of all, and who was the demand for this technology? Does the demand come from some customers, or did you develop this technology and then promote this technology to future customers? Where come from the demand of this technology?
In fact, it's a lot of questions in one. So no problem. I will try to answer. So I think I did not mention, but the different systems I was talking about are not at the same maturity. So for example, the intelligent intersection, this is a system which we sell now. This is really ready, and the pictures you have seen are real intersections in the USA, for example. We are starting now also in Europe. Why, by the way, let me show this also. Yes, so here again, I forgot to mention before. So here's the name of Iteris. So Iteris is a company specialized in intersection management systems, so like traffic lights, and they do the cameras also and so on. And this is our partner. So to answer your question, we started to work with Iteris around about 2 years ago, a bit more than 2 years ago. This is rather quite rather short time of development, but this is also because we are using sensors which are ready. So the radar we use here, this is a radar we have developed already long time ago for vehicles. So to develop the intelligent intersection system, this was mainly system engineering and software, in fact. If I come back to the overview with all the systems. The second system I was presenting today, the automated valet parking, is not yet ready for commercialization, for sales. It's our target is to launch it in 2024. So there is still a long way to go. And to answer your question, for such a system, we are talking about a lot of development engineers. And we started already round about 1 year ago, and it will take us a bit more than 2 more years to have it really ready for. So you see, we are already able to do something. You have seen the video. This is real, but this is a demonstrator, and I was also insisting on safety. To make sure such a system is safe, you need also a lot of development efforts. Does it answer your question?
Yes, yes. Thank you.
Okay, welcome.
J'ai pas de questions. I doesn't have any question from the chat. What about there's a question, do you need a special environment to be able to put these technologies in place? For instance, I mean, if we are
which one are you talking about? This one?
Intersection intelligence.
Intelligent intersection, any intersection, anywhere. By the way, I forgot maybe to mention also, why do we use also radars? Because there are already intersections in the world with cameras. This is already existing. The advantage of radars is, well, when you have a camera, when it's night, you have not so good picture than in the day, or when it's foggy, or when it rains, or when it snows. The radar doesn't care. The radar sees everything always. There are some cases, if you have really very, very heavy snow, okay, then it may become difficult, but otherwise it's really very reliable and very independent of weather. So coming back to your question, anywhere, intelligent intersection you can do anywhere. And for the, maybe to complement, for the automated valet parking, it's basically around about the same answer, because it's not difficult to install cameras. Everybody's able to install cameras. It's easy. And really, we use here, we use technology. Those are cameras powered on Ethernet. So you need cameras, you need Ethernet cables, like the network cables we have here for the computers. It's all available technology. There is no. It's in terms of technology, it's all available. There is no special challenge. What is challenging is to develop the system in a safe way. So that means each component of the system must be safe or redundant, if not safe itself. And what is challenging is, you understood it, also basically the software, the artificial intelligence. This is the challenge for the development of such a system.
Okay, thank you very much, Mr. Maire. I can close then the webinar. Just before closing the seminar, I wish to mention that the next seminar will be taking place in Barcelona the 20th of April, and the topic will be Women's Mobility Patterns, and it will be at 5 p.m. So we are ready for you, and thank you very much for you to be here.
Thank you.
Thank you.